This is Mr. Beck Does Your Homework, AP Physics Homework 3.2, questions 14 and 15. There's some information that's in this picture that you've got to pay attention to. Two blocks are attached by a thin, inextensible string over a frictionless, massless pulley. There is a frictional force between the block on the incline and the incline. The acceleration of gravity is 9.8. It tells me that the acceleration is 0 meters per second squared. That's a good thing. That means it's moving at a constant velocity. It also tells me that it's moving at 1.1 meters per second. And that must be my constant velocity. Calculate the magnitude of the frictional force acting on the block on the incline. Well, that block on the incline has a couple of forces on it. It's got gravity pulling down. It has a tension pulling this way, which they label as just big T, so I'm going to write just big T. It's got a normal force pushing this way. And since there's friction and it's moving up the ramp, I'm going to say friction must be down the ramp in this case, because it's opposite the direction of motion. If I want the frictional force acting on the block, I want to solve for this. Well, if it's moving at a constant velocity, I think I can figure out my tension. And I've also got a component of gravity here. So let's split up gravity and see where that takes us. My force of gravity is directed in two ways. It's directed down and it's directed in. So this is my force of gravity into the slope. This is my force of gravity down the slope. And I know that this can be drawn this way, with this being the angle theta, the angle of the ramp, 27 degrees. So I know that my force of gravity down is going to be my mg sine theta, because it's opposite, and this one is going to be mg cosine theta. So if I want to deal with all my forces up and down the ramp, I know that if I redraw my free body diagram, I've got force of friction this way. I've got my Fg down this way in the same direction as friction, and I've got my tension up that way. And since it's moving at a constant velocity, I know that my tension is going to equal my force of friction plus my Fg down. But how much is tension? Well, if I look at my other free body diagram for this block, it's simply got a tension up and it's got a force of gravity down on it. And since it's moving at a constant velocity, I know that this force of gravity and this tension must be equal. So this tension is going to be the force of gravity on the hanging 13 kilogram block equals the force of friction plus the force of gravity down the block. And I want to solve for the force of friction. So that's going to be the force of gravity minus Fg down. Now, if I plug in a couple numbers here, I see that the force of friction is going to be the force of gravity, which is going to be the 13 kilograms times my acceleration of gravity, which is 9.8, minus my force of gravity down the slope, which is mg sine theta. So that's also going to be 13. That's this m. It happens to be the same number for me. If you have a different number, then sorry. But I've got 13 kilograms on the top as well. So this 13 is this hanging one here. So this Fg is this one. Minus 13, that's this one up here, times 9.8 times the sine of 27. So that will give me my force of friction. Simple math there. Will give me my force of friction. Now I want the coefficient of friction. To get the coefficient of friction, that's going to be mu, is going to be my force of friction divided by my normal force. Well, I just solved for my force of friction. And my normal force here is going to be the same as force of gravity down. Since it's not going in and out of the page, I know that with my this force of gravity into the page is going to into the ramp is going to equal the normal force up from the ramp, so it doesn't jump off the ramp or go into the ramp. So this is going to be over mg sine theta, mg cosine theta. So that is going to be my force of gravity down is going to equal my force of normal. So I can do that, and then I have my mu, because I got my force of friction and my force of normal. And that will give me my coefficient of friction between the block and the surface.